This is page 10 in our notes. My colors are purple and black. This is NS.4. This is least common multiple. So this is the worksheet that you were doing, the 1.3 worksheet you're going to continue working on for your least common multiple. Something cool about this is I want you to put a box around the L like this. That is what we're going to do today with this lesson with the ladder method as well. So least common multiple, we need to first talk about common multiples, just like we did with factors. So common multiples. Basically, it has to be a multiple of a number, but they also have to have it in common. So it would be like a number that is a multiple of two or more numbers that they have in common. So my example of common multiples, unfortunately, the list method is the old school method that many of you learned. Some of you even made it like an M when you were writing multiples. And that was basically like if I asked what are common multiples of 8 and 12, you would list them out like 8 and then 12. So listing multiples means you skip count by them. So you would skip count 8, 16, 24, and I'm going to stop because 12, I know when I'm going 12, 24, I already found one that they have in common. You can find the one that they have in common by listing them out, and you can circle it. What's kind of cool is the next common multiple that they have in common is 24 more than that. So if I add 24 more to this, the next one they have in common is 48. And then if I add 24 more to that, the next one they have in common is 72. And if I add 24 more than that, the next one they have in common is 96. So I call this the list methods. Depending on how long you list, it might take a while until you finally get a common multiple. Once you find the first one, then you can continue on finding the others. The first one is actually what we call the least common multiple. And so like I said, once you find the first one, the other ones are just that many away from it. So you just keep adding 24 to get to the next one and add 24 to get to the next one. And you could keep listing, but you may not want to list forever because multiples go on and on forever. So what is this standard? This standard is talking about least common multiple. Well, the least common multiple, or the LCM as I like to abbreviate it, and I like to put a box around that L because that's what you're going to do in the ladder method in a moment. Of all the common multiples that they share, which one's the smallest? So it would be the smallest of the common multiples. And there's nothing wrong with the list method here, but I do want to show you the ladder method because I really do like it. The ladder method would be like a continuation of what we were doing with greatest common factor as well. So I would like you to use the ladder method when finding the least common multiple. So box that in for the ladder method. So what is the LCM of 8 and 12? Just like we did up here when we listed 8 and 12, we got to the least one. You could do it with the ladder method. So you would put 8 and 12. And do I make a rung on the ladder? Yes, I do. What would go into 8 and 12? Remember, this number out here has to be prime, so I could put like a 2. 8 divided by 2 is 4. 12 divided by 2 is 6. I can make another rung on the ladder because there's another prime number that goes into both 4 and 6, and that would be 2. And I end up with 2 and 3. And do I make another rung on the ladder? 2 is prime. The only thing that goes into it's 1 and 2. And if I try to put a 1 or 2 out here, it's not going to make 3 any smaller. So here's why I really like the ladder method. So with the ladder method with LCM, now you're going to put a box around everything on the outside and the bottom. And you're going to notice it makes a big L. And you're going to multiply the outside and the bottom to get the least common multiple. So 2 times 2 is 4. And then down here, 2 times 3 is 6, but I still have to take 4 times 6, so that would equal 24. 24 is the LCM. What would be the next one that they have in common? Kind of like what we were talking about before. If you added 24 more on, the next one they have in common would be 48. What's the next one they would have in common? It would be 24 more than that, which would be 72, kind of similar to the example we showed up above. So kind of neat here. You found the LCM of 24 by multiplying the whole L. What if I throw the term GCF? Do you remember what GCF was? GCF was just the side, so your GCF of 8 and 4 would just be 4. So greatest common factor is just the side. LCM is the entire L. Okay, let's do another example over here to the right because we have some room. What is the LCM of, and I'm going to do 8, 10. And I'm going to make a rung because I know there is a prime number that goes into both of those. That prime number is 2. I can divide 8 by 2 and get 4. 10 divided by 2 and I can get 5. 4 and 5, like if I were thinking like a number line, they're right next to each other in a number line, which means they're only one number apart. They're not going to have anything in common to divide by to make them smaller because there's only one number apart from them. So I can't make another rung on the ladder. Nothing would go into them to make it any smaller. So LCM means I have to multiply the entire L to get the LCM. That's 2 times 4 times 5. Well, if I do 4 times 5, that's 20. And if I times that, this 2 times the 20, I should get 40 is the LCM. Okay, I'm going to throw a little curveball at you. What is the greatest common factor of 8 and 10? So if I ask for greatest common factor, remember GCF is just the side. So GCF would just be 2. So I kind of like the ladder method because you can actually find the greatest common factor and least common multiple of two numbers all in the same problem. Let's try 2 more examples. On the left, I would like you to find the LCM of 3, 7. 3 and 7. What is the least common multiple of 3 and 7? And 3 is prime. The only thing that goes into it's 1 and 3. If I try to put a 1 out here, make a rung on the ladder, and I try to divide by 1. 3 divided by 1 is still 3. 7 divided by 1 is still 7. So it's like I didn't even change the problem. If I really try to multiply this whole L, 1 times 3 times 7, I get 21 for the LCM. Some people notice, well, when nothing goes into both of them, couldn't you just take 3 times 7? Absolutely. That's what you can do. All right. So the least common multiple of two numbers when they don't have anything in common is like just taking the two numbers and multiplying them. The first time they're going to have something in common is at 21. What is the greatest common factor? Well, the only common factor that 3 and 7 share is 1. So the GCF would be 1 in this case. Let's do another example. What is the LCM of 5, 12? 5 is prime. The only thing that goes into it is 1 and 5. So even if you try to put a 1 or a 5 out here and divide by 12, it's not going to make it any smaller. So just like we did on the last problem, you don't have to make a rung and put a 1 out there. You could just take 5 times 12. And 60 is the LCM of those two numbers. That's their least common multiple. The next common multiple would be 60 more than that, which would be 120. What is their greatest common factor when they don't have any thing on as any rung? Well, every number has a common factor of 1. So when they don't show anything, you've got to remember that their greatest common factor is just 1 here. Don't say nothing or 0 because they do have a common factor. So the ladder method allows you to find the least common multiple. Once you found the first common multiple, you can actually find the second and the third and the fourth and the fifth if they ask you to keep finding that. So I kind of like the ladder method, again, for this reason. Your homework is going to be that worksheet 1.3 continued. So now you need to do numbers 11 through 18 all. So I think you had done 1 through 8 before. You're skipping 9 and 10, and now you're working on 11 through 18. So you can use the ladder method. You can use your notes to help you with that worksheet.